All right, maybe I should take a picture of all these just so we can. So there's hard ways and short ways to do this. I'm guessing this is one you took a lot of steps on. I would probably not thinking about the theorems. I would have taken a lot of steps too until you think about the different theorems that we have. So we have AC is perpendicular to BC. So that makes this 90 degrees, right? We're tracking. And angle 3 is complementary to angle 1. So angle 3 is complementary to angle 1, or complementary to angle 1. So that means they add up to 90 degrees. But if you think about it, these two have to add up to 90 degrees as well. So we basically just have to say, 2 is complementary to 1, 3 is complementary to 1, and then we use theorem 2, I think it's 7. 2-7 is the complementary one. 2-8. 2-8 is the complementary one. We just use 2-8 to say then these two must be the same measure. I believe that's what they did. We'll just double check. So yeah, they just said angle 2 is complementary to angle 1, and that's because they're 90 degrees, basically. I don't need this. Yeah, I just need theorem 2-6, or I don't even need theorem 2-6, actually. I probably would have taken just an extra step. I would have probably just taken an extra step and just said, because sometimes it's, what was that? Oh, yeah. But honestly, if I was on a test, I probably wouldn't think to go to 2-6. I would just say, hey, angle 2 plus angle 1 equals 90 degrees, definition of perpendicular lines. And then I could just say they are complementary by definition of complementary. So if you didn't remember this one theorem, you could have just said, hey, I see they equal 90 degrees. Why do they equal 90 degrees? And then you get to this next step, which is just restating the given. And then you can use 2-8 just to say they're complementary to each other. So then they have to be congruent. Yeah?
Can I just read what I said? Because I don't think I
Yeah, absolutely.
completely skipped the step.
Shoot it.
So for number 1, I did AC is, well, the given.
The given, yep.
And then I did, for number 2, I did angle 1 is complementary to angle 2. And I put theorem 2-6, and then I did, for the next step, I did angle 3 is congruent to angle 2, and that's theorem 2-8.
Yeah, the only thing we missed is we missed one given.
Okay.
But I wouldn't even take any points off for that because you saw it, not a problem. Yeah.
I understood like the first like 2 steps because it's like makes sense, but like I did a given and then I did like the definition of complementary angle with like angle 3 plus angle 1 equals 90 degrees. So that wasn't there. Like I did that as to like unpack the first part.
Okay, so you unpack this one by saying what?
No, I used like the second. I put both of them. In
Okay, you put both of them?
Step, and then I like unpacked it to say that angle 3 plus angle 1 is 90 degrees, and I did like angle 2 plus angle 1 is 90 degrees because of the definition of perpendicular lines. So I don't know if this is
Hang on. I was going to show this, but this is the perfect time to show it. I think this is exactly what you were trying to do. It just takes a lot more steps, right?
That's what I did.
So I just made them equal 90 degrees.
Yeah.
Replace 1 for 90 and then subtract out stuff. It works.
I didn't do all of those steps.
Okay, as long as I get the whole gist of what you're trying to do. Remember, this is like the epitome of every step that you need, right? But if you said that measure of angle 1 plus measure of angle 2 equals 90 degrees because of definitions of perpendicular lines, I'd be okay with that. I understand where you're going with it. I understand what you're thinking. So this is a much longer way to do it, but it's still correct. There's multiple ways to do these proofs, okay? Don't get bogged down in one way and just, saying, oh, the book did it this way, so I have to do it this way. you're just trying to explain to me why it's true. All right, that is your whole goal, explaining to me how it's true. So, Grace, you might have missed some steps in there, but if I can follow from here to your end, you're probably fine.
Okay.
All right, even if you're missing a couple steps here and there that aren't super key. Right, but I really want to see if you're using this method that this angle equals 90, this one equals 90. Those are the
Okay.
kind of things I'm looking
So,
out
like,
for.
should that be another like step, like putting them together, like the
Yeah, that's what I did here. Because then you can subtract measure 1 out and say angle 2 is equal to measure of angle 3. Okay, yeah.
For some of the proofs, I actually, like, I did it a different way than, like, what showed in the answer key, and I still got the same answer.
Okay. Yeah.
It was-
Those might be times you come to me and just ask me, does this work? All right, I can't check everyone's in the middle of class. I can't check every one of yours to be. That's where you come up to me and say, hey, Mr. Pavian, is this a good way to do it? All right. That'd be a perfect time to do that. Okay, other questions? Is this, Amber, did I satisfy, kind of?
I think so.
Okay. Robin, were you about to raise your hand, or were you just
No.
moving? Grace?
I was like very confused about how to start like 22. It's an extra proof.
Mm-hmm.
Like I understood like the given obviously, but like kind of got confused about how to go from there.
Okay. Yeah, it's kind of a 22. I think I got that guy printed. Let's go ahead and do this.
I wanted to like do something with like 90 degrees because like to combine the two different, like the 4 different measures,
Mm-hmm.
but it didn't say that it was 90 degrees. Like
Right.
that's what we're trying to prove.
Okay.
As like perpendicular.
Let's just talk about it real quick.
Okay.
Because I really think talking about these is much more critical than actually doing the whole proof. Because I keep reiterating this. Don't do a proof, okay? Write down what you think's important. Even if it's not in proof style, just say, hey, Mr. Pavian, I understand that this equals this, which would make it 90 degrees, and that would make it perpendicular. If that's all you can write down, then that's all you can write down. So this one says measure of angle 1 equals measure of angle 2, and measure of angle 3 equals measure of angle 4.
I just had an idea.
Mm-hmm.
Like, could you put like measure of angle 3 equals measure of angle 4 equals measure of angle 2 equals measure of angle 4 just because you know they're like equal to each other, like that they together they like.
Yeah, I see kind of what you're thinking. The way I would do it, and we'll see what the book does, but in my mind, this is what I'm thinking when I'm doing this. All right, if I have two angles that are the same, are congruent, and they add up to 180 degrees, they each must be 90 degrees. Do you remember that theorem? That basically says
Yeah.
if they're both congruent and they add up to 180 degrees, then they have to be 90 degrees each. Or you can just use common sense. You can just say, by common sense. If you can't find the theorem, just say, put something down, all right? So my goal would be, say, angle 1 plus angle 3 eventually equals 2 plus 4. All right, that would be my entire goal. And 22, they just state the given, and then they roll right into the angle addition, all right? Or the addition property of equality, where I just add 3 to both sides. Then we use our angle addition postulate. I would do the angle addition postulate first. I always like to get it out of the way. Because if you have two angles adding up, use the angle addition postulate. Always, if you need to add angles, use the angle addition postulate. All right, use it right off the bat, because at least you get points. And then they just added 3 to this side, 4 to this side. And in short, we're just going to say that these two angles are congruent, and so they have to be 90 degrees.
Okay.
Does that make sense?
Yeah. Oh. Okay.
That's what I
Yeah,
mean.
I just didn't like get how to get to that.
If you get stuck, just talk about it. Talk me through it. Like, if you can't do step by step, just go, okay, Mr. Pavian, I know I need to prove that this angle is congruent to this angle, which will automatically make them 90 degrees. All right? Don't get super frustrated by these proofs. All right? I'm just looking for, do you know the key bits of information? Do you know the angle addition postulate? Right? I'm looking for that. If you need to use it, throw it in there, because every time we did angles, we've used angle addition postulate. All right, one more question, because we're at the 10-minute mark. of just questions and stuff? No? Okay, cool. We're going to go ahead and look at that same exact one that we had questions about. All right, so let's just go ahead and write down our given. Let's write down our given, see if we can get to the answer. Please don't turn to your homework if you have this done, because this was part of our homework. I'm just rehashing it. And that's given. That's given. All right, you could. By all means, you can put this one down next and just put it as another thing of the given. I typically, because these things are so different, I want to unpack what this means first and how it's going to help me, and then bring this one back in. So I unpack what I can, and then bring in that second part. All right, so we have the first step is given. So let's go ahead and unpack that statement, that PQ is perpendicular to QR. So this won't be exactly how the book does it. Yeah.
Would you say like PQ plus QR equals 90 degrees?
PQ plus QR? It's a line plus a line. PQR, yep. So let's just go, and remember this might not be exactly how the book does it, might be a longer version because we're doing it as class, but we'll get it done. So angle PQR, let's just say measure of angle PQR equals 90 degrees, right? And that must mean that measure of angle RSP. And I'm just going to say that's what perpendicular lines means. That's what it means to be perpendicular, that it creates these 90-degree angles. What's probably my next step? Even if I don't know where I'm going, what's probably my next step if I have these big angles? Amber?
Angle 1 plus angle 2 equals 90 degrees. And then you could say that angle 4 and angle 5 also equal 90 degrees.
Mm-hmm. And that's going to be our angle addition postulate. Now this one isn't perfectly written already. Just because technically speaking, I should have said angle 1 plus angle 2 equals PQR. And then I should have said equals 90. I'm good with it like this. I'm good with it like this. Okay? So just be aware we kind of skipped a step, but it's kind of that unimportant step, so I'm okay, because we're just going to make a class proof of this. So now I know that angle 1 plus angle 2 equals 90. I know angle 4 plus angle 5 equals 90. Let's look at what we want to prove. I want to prove that angle 2 equals angle 5. So that means I want to get angle 2 on one side of an equation, and I want angle 5 on the other side of the equation. How can I rewrite this so that they're on either sides of the equation? Hannah?
Angle 1 plus angle 2 equals angle 4 plus angle 5.
Oh, that'd be really nice, wouldn't it?
Yeah.
How do you do that?
Substitute.
Oh, substitution. So we could just take this guy and plug it in for that 90 degrees, right? Which will give me that angle 1. I should really have measures here. I just kind of get lazy sometimes when I'm just writing. Angle 2 equals measure of angle 4 plus measure of angle 5. And that's going to be, it has to be substitution in this one. There's no, and it's because of what I drew. Because we already used the angle addition postulate to say they're equal, Sabrina. I needed to replace this whole thing in for 90 degrees. So I'm taking that whole chunk and plugging it in. I see what you're saying though, because the angle addition postulate was used, but we already listed it. Ooh, sorry, my thing froze in the middle. Man, if we could just get rid of the 4 and the 1, we would have our answer. If only I could get rid of the 4 and 1, so if I could subtract those on both sides. If only I could say they were both equal, then I could subtract them on both sides. If only I could say they are equal. Aiden, what can we do in the next step? Yeah. What's the given we didn't use? Boom. Measure of angle 1 equals measure of angle 4. That's given. Oh man. I feel the finished proof coming on. I could just subtract measure 1 from one side, measure 4 from the other. And my sixth step is measure of angle 2 equals measure of angle 5. And that's going to be our subtraction property of equality. Now, who knows the book answer? No, you don't have to look it up. Oh, you have the answer guide. Is this the same thing the book has? 'Cause I think the book did it in like 4 steps. I'm just saying right now, wasn't this a little easier than what the book said? I mean, there's less steps, but you had to remember theorems. Sometimes it's just if you remember all the theorems and you study them really hard, it can make these proofs a little shorter. But am I going to take any points off for this? No, this is just what we came up with as a class. We just went through this. And typically the book answer is one that when you look back at it, you're like, oh, I could have taken out these steps. I could have used this theorem. But on a test, sometimes your mind goes blank. And just work out part by part by part. That's why I'm showing this one. It's just part by part by part. Think through stuff. Did I use any crazy theorems in here or anything? No. So you don't always have to use those theorems. Even though you can, it makes it a little simpler. Sometimes it's just nice to be able to go through it. Amber, does this make sense? Because I know you had a question on this one. Yeah. Okay, good. Good. Yeah. I'm going to fill in given on this one. And I want you to try the rest. Just remember, you're just asking yourself, what happened from this step to this step? And is probably a property of equality. Bless you. So I want you to fill out the rest of these. All right, let's go ahead and go through these. So the whole idea is what changed from step 1 to step 2. We'll get to the next proof. So let's come back to this so we can all help out. So from step 1 to step 2, what happened? What did I do? Don't tell me what the reason was, but just tell me what happened between step 1 and step 2. It kind of is the answer. Evan.
So you multiplied everything by 2.
Yep.
We multiplied each side by 2, so you got 4x plus 4 times x plus 2 equals 2x plus 6.
Perfect. So I multiply both sides by 2. As soon as you say multiply, it's going to be multiply, or multiplication, property of equality. We just got to add that po onto there. All right, from step 2 to 3, what happened from step 2 to 3? Sabrina.
Oh, my favorite distributive property.
Oh, good. The distributive property. Yep. The distributive property. All right, from 3 to 4, it looks like this 8 changed. How did that 8 change? Lydia?
We added by terms with the addition theory.
Close. Close. You'd have to like really stretch that Amber.
Subtraction.
It's going to be subtraction because I subtracted 6 from both sides. Do you see the subtracting 6? Or 6 from both sides. Remember, if you can really sell me on the addition, like you're adding a negative, you have to sell me on it though, right? On the test apply mark it wrong, you have to sell me on it. Just use subtraction, we don't have to worry about that. All right, from 4 to 5, it looks like this 2x turns to a negative 2x and this 4x disappears. Evan?
Is it subtractive?
It is subtraction property. Subtraction property of equality, and that's because I subtracted 4x from both sides. All right, then we go from here to here. Jacob, what happened in the last step?
The division.
The division property of equality. Good. Robin.
There's the.
Yeah. All right, let's just do this next one together. All right, some of you might have started it. We're just going to do it together and see what we come up with. All right, I'm going to give as little input as I possibly can. So my first step is I'm going to list the givens. RP equals TQ and PS equals QS. That is given. And what I might do is on the drawing, I would say RP equals QT, PS equals QS. Now I want to prove that RS equals TS. So that makes sense, right? All those segments are congruent. Yeah.
Like on the test, like, cause I know how to figure this, kind of, like, I can figure this out kind of, like, mentally, kind of, like, by, like, cause you already kind of switched them around, like, in my head, like, I already, like, switched them around, so it's, like it wouldn't only, like, kind of take 2 steps, or?
It won't take 2 steps. No, it's going to take more than 2 steps. What's our next step going to be? What's our next step going to be? Lydia?
Segment RP plus PS equals RS.
Yeah. So I'm going to say RP plus PS equals the total length RS. And I'll probably do it the other side too, right?
Yes.
So I'd say TQ plus QS equals TS. And we know to do that because your first step should always be I got a bunch of segments, add them together to make the big one. All right, segment, angle addition, those should be the first things we think about. All right, so I have this equaling this equaling that. I need somehow to get to RS equals TS. Grace, do you have our next step?
Yeah, you can use substitution and do RP plus PS equals
TQ plus QS, because, well, that's not really substituting, but like, you're,
No, it's substituting.
oh yeah, cause like, you know.
Well, it's not. It's really addition. Let's go through that. So I forgot to do my second step. So I have segment, addition.
Flip those two, like.
Yes. So the third step, you said somehow we should have RP plus PS.
I don't know the reason, but
equals-
it's just 'cause it's the full line.
Yeah, I got what you're saying. So the official reason why you might use this, if you really stretched it, you could think substitution, because I could just substitute that in for that and they equal. The 100% correct one is actually the addition, because I'm adding PS to one side, so I can add QS to
Not
this
segment
side.
addition,
This one's segment addition.
but just regular addition.
Would this one be segment addition? No, it would just be the addition. Property of equality. Who had a different one for this one? I know substitution. I would probably accept substitution. Thinking about Lydia.
I kind of just did RP plus PS equals TX.
Oh, you're like.
Yep.
Went straight to that.
Yep, we went this way, but yeah, hers is gonna be a little quicker. Might be a little quicker just because she jumped straight to A and TS, and now she can just substitute RS in there. So your way is gonna go a little faster. Okay, but we're fine going this way. Well, they're both the same. Because what does RP plus PS equal? Oh, we're stuck. What's my next step? Hannah.
I was just gonna say substituted in because we know that RP plus PS is RS and then PS is the.
Yeah, that's a good way. Lydia, I wouldn't erase yours, because yours is fine too, so I'm going to substitute that in there. I'm going to substitute TS in for that. And so I can jump right to my answer being RS equals TS, and that's going to be substitution. I want to talk about Lydia's way real quick. So Lydia, she just replaced TQ for here an RS for here, or QS for here, so she probably says something like TQ plus RS plus QS equals RS. All right, so she put that in there, put that then in there, and then your next step is done too, because you can just replace TS for what you just did. Yep, that's 100% correct. Sabrina, do you get why it couldn't be done in 2 steps?
Oh, well, I did it like using substitution, so like I kind of like if it said RS, and then so I know that P is probably like equivalent to S, and then I assume that
You're making a lot of assumptions though.
yeah.
You have to do it this way. You can't just say, I assume it's correct because I know it's correct. You have to show these steps.
Oh.
All right, you have to prove it. You have to prove it, and those steps are the best way to do it. All right, any questions on that one? On your desk is a review. I will post the answer key today. I forgot to actually post it. I'll post the answer key on it today. So I have this down, right? Let's try these. I'm not going to look at them. I'm not going to correct them for homework. But I do want you to get a good start on that review. So it doesn't mean the review has to be done, because tomorrow we'll have time to work on the review in class. But you probably shouldn't come in here and have a blank review, because then you can't ask questions. Right? A good idea is maybe pick the ones that are really hard, try those tonight, and then come with questions tomorrow and just work on the easy ones that you think you can get in class during class. Okay? So try these, look at them at the very least, and get a good start on the review that I handed out so we can ask questions tomorrow, and we can hopefully have it done by the end of class so you have stuff to study for tomorrow. All right? Does that make sense?